Have you ever wondered how cool it will be to create your own mobile application that can run both on iOS and Android devices? I'm Tony, and I'm here to show you an easy way to get started in the mobile applications world. In this course, I will teach you how to create from scratch a simple login application using React Native. React Native is the most popular cross-platform framework for developing mobile applications. The popularity comes from the fact that developers still write with React code, but it is shared across iOS and Android. This course is a step-by-step demonstration of solving some of the most common problems we encounter when building an application, including project setup, screen navigation, user authorization, and state management. This course is perfect for beginners in mobile applications programming and those who want to improve their React Native skills. The course is divided into 5 modules comprising 16 lessons. We start from the introduction, where we set up the project with Expo. Then we move to navigation and creating basic screens like login screen and register screen. Next, we add authorization with Firebase and implement more advanced features in our application, like bottom navigation and drawer menu. After finishing this course, you will have all the knowledge to create production-ready application that can be released to App Store and Google Play. I'm super excited to share my knowledge and explore the wonderful world of mobile applications with you. Let's get started. The course is divided into 5 modules comprising 16 lessons. We start from the introduction, where we set up the project with Expo. Then we move to navigation and creating basic screens like login screen and register screen. Next, we add authorization with Firebase and implement more advanced features in our application like bottom navigation and drawer menu. There is a full source code provided that you can download for this course. I would highly recommend creating a new project from scratch and building the application along with me. That way you will see your progress and be able to add your own modifications. This is how our final product will look. I'm very excited to have you here, and I can't wait to show you all the amazing things you can build. Let's get started. In this lesson, we start from the absolute basics. We are going to install all the necessary libraries and set up our project. If you have previously worked with JavaScript, then you probably have Node installed on your device. If not, please visit the Node.js website and install it. If you want to check your current Node.js version, simply use this command in your terminal. I recommend using Node.js version 10, since this is the one I will be using in this course. For creating our React Native project, we are going to use Expo, which is an open source platform for making native apps for Android and iOS using JavaScript and React. There is also a way to create project using React Native command line interface, but it has some drawbacks, and if you are a beginner, I would not recommend doing it that way just yet. Expo simplifies most of the time-consuming work, like building your app and releasing it to the App Store and Google Play. It also doesn't require you to modify any of the native code using Xcode or Android Studio. Before creating the project, we need to install Expo command line tools using this command. Once this is done, we have all the tools we need to create our project. Open the terminal at your desired project destination and run this command. When creating our project, we have a few templates to choose from. We are going to select blank. If you prefer TypeScript, there is also a template for you. After a few minutes, your project will be ready. You should see the following output. It is always a good idea to check if you are able to run your app and see if it works. If you want to open up on an iOS simulator, you can run the following command. You can also open the app on an Android emulator by running the command npm run android. Since I'm on the Mac, I prefer using the iOS simulator because it performs better and loads faster. After a successful build, you should see your application. If everything works, take a look at the project in your editor. Starting at the bottom, we have our package.json file where we can see a list of all available scripts and currently installed dependencies. Installing any new library will update this file. In every Expo project, we also have an app.json file, which contains all the metadata for our app, like the app's name, bundle identifiers, and more. During this course, we are going to edit this file several times. Lastly, we have our app.js file, which is an entry point for our application. We'll start building our application from here. As you can see, changing text inside the text component immediately changes content in our app. We can delete the status bar component since we are not going to use it in our project. One thing I like to start with is creating a source folder where all our components and screens will be. At this point, we are almost ready to get started with our application. In the next lesson, we are going to add some of my favorite libraries that make the whole experience of developing apps more pleasant and elegant. Thank you and see you in the next lesson. In this lesson, we are going to add two libraries which will improve our development experience. ESlint and Prettier are libraries that together make your code more universal as they make you stick to common programming style guidelines and patterns. ESlint is a code linting tool that handles code quality and resolves coding style issues. If you are using Visual Studio Code, I recommend this ESlint extension. You can find it by typing ESlint in the Extensions tab. Prettier is a code formatter that will take care of code quality. In Visual Studio Code, there is also a dedicated Prettier extension. You can find it by typing Prettier in the Extensions tab. The next step is adding ESlint and Prettier to our project. Doing it manually can take some time, so I recommend this GitHub repo that comes with one command line that installs all the needed dependencies in our project. After executing it in a terminal, we have a few options to choose from. Select Package Manager, in my case it's npm. Select configuration file format, I recommend using JS. Enter max line length, 80 is the most common and recommended. Select trailing comma style, I recommend selecting ES5. After all the dependencies are installed, we can take a look at the generated files. In our project, we can see two new files, PrettierRC and ESlintRC. They come with some default rules, but these are not enough for our React Native project. In the full source code for this course, you can see the complete configuration files that are tested and used by me. You can simply copy and paste them. They add some more specific rules helpful for React Native projects. Now, let me show you a small example of what exactly ESlint and Prettier can do for you. Let's define the following variable. As you can see, our code editor links one warning and one error. The warning simply tells us that the variable test is assigned a value but never used. This helps us to avoid defining variables that are never used in our code and yet take up the memory. The error is linked by the Prettier rule that removes any unnecessary semicolons to make our code cleaner and more readable. I know that it might be surprising to some of you, but in JavaScript, semicolons are not really necessary in most cases. Errors will be taken care of automatically when I save the file, thanks to Visual Studio plugins. To sum up, after installing ESlint and Prettier, we no longer have to worry about styling issues and can focus on the functionality of our app. In the next lesson, we are going to add a design system to our app that will provide us with components such as buttons and text inputs. Thank you and see you in the next lesson. In this lesson, we are going to add a design system to our app. A design system is the single source of truth which groups all the elements we need to design and develop our app by providing a set of components. It also saves us a lot of time by solving all the major use cases like creating layouts in our application. My absolute favorite when it comes to React Native is React Native Paper. It is based on material design, which provides us with easy to use and well-designed components like buttons and text inputs. You might ask if implementing a design system is essential. The answer is no, but it really speeds up the development process. All components are well tested and used by thousands of developers, so we don't have to worry about the implementation. Installation is very simple. We use the following command to add React Native Paper to our app. After installation is done, we can start the implementation. First, we need to wrap our app with the provider component from React Native Paper. Provider adds the theme to all the components in our application. It also acts as a portal to components which need to be rendered at the top level, for example modals. By theme, we mean all the colors and fonts that our components will use. I created the theme.js file to modify default colors and add some new ones. To use our theme, we must pass it to the provider component as a prop. You won't see any changes in the app yet, because we only set up the theme for future use. Let's actually test some components and see how they look. We will start with the button component. We export button from React Native paper and place it in our app. As we can see, it is nothing special just yet. We add prop mode contained to make our button stand out in the user interface. For the purpose of the scores, I created a little abstraction over the button component to add some extra styles to it. It will make our button bigger and make it fit to our screen more. We can replace the current button with our own implementation. One thing worth noticing is that the color of our button is actually taken from the theme that we provide. For example, if you change primary color to red, all buttons in the application will turn red. The same goes for text and background colors. The second most important components in our app are text inputs. React Native paper provides the component text input that looks amazing and takes care of all the animations. We are going to use it a lot in our application. I also created a little abstraction over text input that adds some extra styles to it. I implemented additional props, description and error text, so we can control what is displayed below the input. This will be very useful later on. It is always a good idea to add some basic typography to our project. In our case, we are going to add header and paragraph components. They will be used to display important information on the screen. As you can see, we are using the text component exported from React Native paper instead of the text component from React Native. This is because we want to ensure that our text will use the colors provided in our theme.js file. To sum up, we have added a design system to our app with React Native paper. Now we have more components to build our application with. In the next lesson, we are going to add another great library to help us with screen navigation. Thank you and see you in the next lesson. In this lesson, we are going to install a React navigation library. This is the most popular library for routing and navigation in React Native apps. It also supports applications created with Expo, another reason we have chosen it for our app. Every good app needs a good navigator. Just like a cross-country trip, a good navigator takes us from place to place in our app, ensuring that we get to where we want to go. A bad navigator takes us, well, where the navigator wants to go. We get frustrated and put the app down, lowering user engagement. You might ask what navigation is used for. Well, the most common cases are bringing the user to different screens in the app, providing a back button to bring the users back to the previous screen, passing information from screen to screen, creating a navigation menu in our app such as bottom navigation or drawer. React navigation easily meets all the use cases just by default. We have to remember that navigation on Android and iOS is a little different. In Android we have a back button and on iOS there is a finger gesture for moving to the previous screen. With React navigation, we don't have to worry about all that because it's done for us by default. We do still have to remember those little differences when implementing our user interface. For example, in most cases, we don't need a back button on our screens because users are already familiar with the system way of going back, like the back button in Android or iOS go back gesture. Before we can use navigation, we must understand a few terms. The React navigation glossary of terms is very helpful. I would recommend going briefly through it because they are the basic you should know before using the library. Now, let's install all the dependencies we need. We have to run two commands. The first one installs the root dependency, and second one, since we are using Expo. There are a few dependencies that you might be surprised to see. Those extra dependencies are used for taking care of animations and gestures. For example, React Native Reanimated is a well-known library that React Navigation uses for making transitions between screens. We are all set up and our application is ready for implementing navigation. In the next lesson, we are going to create a few simple screens and perform transitions between them. Thank you and see you in the next lesson. In this lesson, we are going to actually use the React navigation library in our app. We start by wrapping our application in a navigation container, which is responsible for managing app state and linking a top-level navigator to the app. This component is necessary since it will be treated as the root of navigation in our app. It will also take care of actions like pressing the back button and notifying of state changes for screen tracking. In our application, we will use the most common navigator, Stack Navigator. This is exactly what it sounds like, a stack. It provides exactly what it sounds like, a stack of navigation. We create a stack using the following code. The React navigation stack dependency is missing in our app. We have to install it by running this command. Once we have that, we put stack inside our navigation container. If we put it somewhere else, we'll get an error when running the app. For now, we can move our current code and comment it out. As we can see, the code doesn't do much. We get an error because we don't have any screens yet. What we have done is basically a setup for our future screens so they can be added to our stack. Our screens will be a set of interactive components connected into layout and displayed to our users. Let's create the first screen. We can simply copy the code we already have in app.js file. Now we can add the screen to our stack navigator. We give it a name and component to render. We can see our screen now. One thing worth noticing is that by default we show a header on top of our screen. In our application, we don't really need the header. We can easily hide it by adding the following prop to our stack navigator. The header is gone and we can continue developing our app. Having one screen in our application isn't really exciting. Let's create a few simple screens that we can use later. Let's add our screens to Stack Navigator. Make sure to provide a different name for each screen, otherwise we'll run into errors. As we can see by default, the screen 1 is shown since it's the first child. We can change our initial screen by providing the initial root name prop to our Stack Navigator. For now, let's change to the first screen. Right now we can't really see other screens. That's because they are not added to our stack yet. In our current stack, there is only screen 1. In the next lesson, we are going to learn how to add other screens to the stack and perform transitions between them. Thank you and see you in the next lesson. In this lesson, we are going to learn how to perform simple transitions between screens in our app. In the previous lesson, we created 3 simple screens to play with. Right now we are only displaying screen 1 and can't really do anything else. Before getting into transitions, let's make some changes to our screens to distinguish them. Each screen is going to display a header with screen index. To understand navigation in our app, we must start from the basics. Each screen in our Stack Navigator has the prop called navigation. If we console log navigation, we can see that it contains various functions that dispatch navigation actions, like navigate, which is used to move between screens. Here we can find a full list of available actions with a short description and what they do. In this lesson, I am going to show you how to use the most important ones. In our project, we'll use 4 methods: navigate, go back, reset, and replace. I will be explaining the methods in detail once we'll start coding. Let's start with a simple transition from screen 1 to screen 2. For that, we need to add a button to our screen. It will have an on-press action that will take us to the second screen. The easiest way is to call the navigate method with the name of the screen we want to go to. In our case, it is screen 2. After clicking a button, we move to the second screen, just as we wanted. You might ask, if the navigation in our app is a stack, then surely our screen 1 should be below screen 2. The answer is yes. On an iOS simulator, we can use a finger gesture to move to the previous screen. The same behavior is achieved on Android when we press the back button. Now, let's see what the implementation of the back button can look like. As I mentioned before, it's quite a rare case, but it's important to understand how it works. Android gives us a hardware back button which is not a part of user interface. We want to create a back button that will be visible on our screen. We again start by adding a button. We also need on-press action. The difference is that now we'll have a function called go back. Here we don't need to specify the name. It will always take us to the previous screen. It works exactly like our finger gesture, but in some cases you might need a more direct way to show your users that there is an option to go back. Another very important method that navigation provides is called reset. It allows us to replace the current navigator state with a new one. For example, you want to use the reset method when a user logs into your application and no longer want the login screen to appear in your stack. That way, you can prevent logged in users from going back to the login screen. We will use this method in a few places in our app. That's why I want to show you how it's different from other methods. Let's add a button that moves to screen 3. Let's use the reset function. The index tells us from which screen in our new stack we should start from. In our case, stack has only one screen, so we don't really have to provide it. We also have to provide a roots property as our new stack. We provide screen 3 as our first screen. As you can see, it behaves exactly like our navigate method. But there is one big difference. Here we can't go back, because screen 1 was removed from the stack. We can implement the back button like we have in screen 2 and see what happens. We get an error because there is no screen to go back to. This is the main difference with the reset method. It can be used to prevent some unwanted transitions to previous screens when we don't really want them. The simpler version of the reset method is called replace. It replaces our current screen with a new one. We can achieve almost the same result with less code. The only difference is that it replaces our current screen and does not reset the whole stack. If we add replace functionality in our second screen, we can see that even after moving to screen 3, we can go back. The second screen was replaced, so we went to screen 1. At this point, we have knowledge of all the navigation methods that we'll use in our application. Having all that, we can finally start making our app functional. In the next lesson, we are going to create a simple welcome screen in our app. Thank you and see you in the next lesson. In this lesson, we are going to build the first screen in our app. It will look like this. It's the simplest screen to make because it doesn't have any inputs. We only have a logo at the top, some text and 2 buttons. Right now in our app.js there are 3 screens components that we use for learning about navigation. Let's clear all that. Now, let's create a screens folder. There we create an index.js file that will export our screens. First we have to create our screen. It will be named startScreen.js. Let's add some basic code and create a view component. As you remember in previous lessons, we already created some of the components visible in the picture. In fact, the logo component is the only one that is missing. We will add it later. We can start by adding the header component to the screen. Let's put login template text inside it. Now we need to export the screen. We do that in our index.js file. Once that's done, we can add the screen to our stack. We change the name to start screen. It is important to change initial root name prop also. Otherwise, we'll get an error. Let's run our app and see if it works. We can see that our header is there, but it is displayed on the top left side of the screen. We can change that by adding styles to our container. We can copy those styles from app.js and move it to our startScreen.js. Now let's add container style to our view component and see if that works. Perfect, our header is centered. The next step is to add text below the header. We already created a component called paragraph that can be used here. Let's put some text inside it and see if that works. Excellent, our screen is looking much better, but we still need to make it more interactive. The best way to do that is to add buttons to it. We are already prepared for this since we created our own button component. Let's use it here. The first one is the login button. We pass prop mode outlined to it. If we take a look, we can see that the button has been added to our screen, but it takes up too much space. This is because our container isn't perfect just yet. Let's fix that. We need to create a component that will be used as a wrapper for all our screens so we don't have this problem in the future. Let's create a file called background.js where our wrapper will be. For the purpose of this course, I created this little wrapper to solve our problem. It adds some extra padding and set the maximum width for our screens. It also uses keyboard avoiding view, and I will explain why in the next lesson when we are dealing with inputs. Let's use this wrapper on our screen. We can remove previously defined styles. After refreshing up, we can see that the login button is nicely placed. Sign up is our second button. The difference here is that for this button we must use the contained mode, so it will look more like a primary button on the screen. By primary button we mean the interactive part of the user interface that stands out, and which users will be more likely to click. It looks amazing, but we are still missing a crucial part of our app, the logo component. Let's create a logo.js file and create our component there. The code isn't really complicated at all. We just use the image component provided by React Native and add some extra styles to it. Make sure to create an assets folder and put your logo file there. Otherwise, nothing will show. Now we put our logo component on top. In this lesson, we successfully created the first screen in our app. Right now, the buttons do nothing, but we'll take care of that in the next lesson, where we will start playing with inputs and other exciting stuff. Thank you and see you in the next lesson.